Properties of logarithms. To change a base formula is used mainly for calculators. Now what it states is this: if you have log base a of x, what that means is that you can rewrite it as a division of two different logs, log of x over log of a. Now the b can be whatever base you want it to be. Now since we are using a calculator, we're going to use either log base 10 or ln, which is natural log, because both of those are on the calculator. But the way you remember this formula is, since when you read log base a of x, a is the base goes on the bottom. Let me say that again. The base goes on the bottom. So that's why we have log of a on the bottom of these, because that's the base and it goes on the bottom. So now, using our information, we can find log base 2 of 3, which means we can write that as log 3 over log 2, because the base goes on the bottom. And you take it out your calculator. Now be very careful how you type this in. So it's log of 3. Make sure you close that parentheses. If you don't, you get a wrong answer. Divided by log of 2. And we get approximately 1.585, depending on how you want to round. Just another one, log base 4 of 9. So let's do log, well, we better write this down before I type it in so you know exactly what to do. That's the same as log over log. Not log of 9 over log of the 4, because the base goes on the bottom, and 4 was the base. Log of 9 divided by log of 4. And we get approximately 1.58 5. I just noticed that's the same thing, isn't it? You can also use natural log of 9 divided by natural log of 4. It doesn't matter. You get the same answer. Does not make a difference at all. We'll use either log or ln. So now we have a question like this. And by the way, the change of base is used mainly for the calculator. Big deal. Now we can graph log base of any number of x. Before you could only graph log of x or natural log of x. Now I can graph log base 2 of anything. And the reason why I can is because that's the same as log of x over log of 2. So let's type that in. That's the change of base formula. That's what I used. So let's hit log of x, make sure you close parentheses, divided by, oh, don't want to hit that, log of 2. So make sure you type in log of x divided by log of 2. Hit graph. And we get the same shape that we would expect to see for logarithms. Change of base. Really handy. So now you have 3 additional properties that we have to look at. Sum, difference, and multiple. Now, what this one is, sum property, if you're taking the log base a or log whatever, I'm just going to say log of 2 numbers or 2 expressions or 2 variables or whatever being multiplied together, you can separate those. So this is all separation. So you can separate a multiplication by using addition, and that corresponds with the exponent rule. When you multiply, you add. And with the difference property corresponds with when you divide, you subtract. It's the same thing. So if you have division, you'll separate using subtraction. That's separating to 2 different logs. There is no distributive property for logarithms, but you can separate multiplication and division. Now this multiple property, it's actually the same as this sum property. And what it really is saying is that p, that's an exponent on the m, it moves out in front. Now if you want to see quickly why I say it's the same as this property, if you were to look at this example, log m times m, and by the first property we can write that as log m plus log of m because we can separate multiplication by addition. You can always put a 1 in front of those. And then what's 1 log of m plus 1 log of m? Looks like to me that's the same as 2 log m. Well, why is that the same? Because m is the same as m squared, is it not? And if you notice, the 2 ended up being out in front, which is what this multiple property says. See, if you have an exponent, it can move out in front. So, there's 3 more properties you have to know. And from previous videos, we had 4, so we have 8 total that we have to know, and that's all we have to know. We'll write those down here in just a few minutes. But let's look at these properties. Now, when it says expanded form for this example, that means we're going to write it with multiple logs. So when you see this log base 2 of x and this is times y, that means we're going to use this first property that says we can separate multiplication by using addition. So that means I'm going to write it down as log base 2 of x and log base 2 of y, and we separate by using addition. And that's it. That's all it's saying. You separate multiplication by using addition. This one is also multiplication. Doesn't matter what the base is. It works for the natural logs. We got 2 times x. So this is the same as natural log of 2 plus natural log of x. Now this next one is a little bit more intense. I'm going to do it in 2 steps. First thing you'll notice is we have division. So we can separate division. So we have log of 2x. When we have a division, which means to separate, we use subtraction. That's the second property. When you have division, you use subtraction to separate if you want to expand it. Minus log of 3y. But we're not done because we have multiplication here and here. So we got to expand those. So we now have log of 2 plus log of x minus log of 3, and I'm going to skip and put log of y. Now it may be tempting to put a plus there. You can only do that if you use the parentheses around there. Here's what I like to do, and I think it's easier to do it this way and fewer mistakes are made. Since we're subtracting all of this, log of 3y, that means we're going to subtract the log 3, and we're also subtracting log y. It's actually the shear property being applied. I know it's multiplication. If you want to think of multiplication, you can, but make sure you use parentheses. Then do addition, which means we have another step. So, if you want to think of it this way, 2x is multiplied, so we separate it with addition. 3y is multiplied, so we separate it with addition. But keep in mind, we're subtracting all of that. So I'm going to distribute that minus sign through it. And that's the best final answer. So be aware of that. However you want to do it, it's up to you. Now this one right here, log base 3 of t to the 5th. See that exponent? It just moves out in front. Becomes 5 log base 3 of t. And that's it. Now we got a few that might not be as easy. Well, you may not think this is easy, which is a strong possibility, but that's okay. We have this one. Now this natural log of square root of x, we're gonna rewrite that x, or square root of x is x to the 1/2 power. Remember, hopefully you remember, if you've seen another video where I talk about this, there's an exponent rule apply here. The nth root of a to the m is the same as a to the m over n exponent. The n moves out underneath as your denominator of the exponent, which now means I can take that 1/2 and it moves out in front of the whole natural log. See that? Let's do this next one. Once again, remember this is a 2 on the outside. So I can write that as, well, you know what I'm going to do? Here's the easiest way to do it. First thing I'm going to do, I'm going to take that 2 and I'm going to divide each of those bases with the exponent. The x is raised to the 4th, the w is raised to the 1st. I'm just thinking which way is the easiest for you to think about. Yep, I think that's the easiest way. So I'm going to write down log, and then I'm going to write it as x to the 4 over 2 over w to the 1 over 2. Let me erase that, make it a little bit clearer to see in case you're just looking and not really listening. So I'm dividing 2 and the 4, I'm dividing 2 and the 1 because all that is under the radical. So now what I can do is I can think of this as log of, watch this, 4 over 2 is the same as x squared. And then we're going to leave w to the 1/2. Then we're going to take this, and we have division, which means we can separate with individual logs. Since it's division, we'll use subtraction. And the last thing we need to do is move the exponents out front. 2 log of x minus 1/2 log of w, and you're done. Now this one is very similar to this one. We already have the index and the exponent, so we just rewrite it as 3 over 4, but be very careful. It's not the exact same as that one, because the natural log, the base of the natural log and the base of the e are the same. They cancel out and it leaves a plain old 3/4. So tricky there. Don't assume because you're in one section that you may not see things from other sections. Now we can also go backwards. When it says condense to single log, that means our final answer is going to be a single log. Makes sense, doesn't it? In this case, a single log base a. Now we have addition. Since it's addition, that means we can combine those by multiplication. What it is this property up here going this direction. So that's what that means when it says condense. Going the opposite direction. This one, see the number in front? We can move it out as the exponent. Make sure you use the parentheses. I guess most systems may take that, but if they don't, they want more. Raise each of those to the third power. So 2 cubed is 8, and then x is also raised to the third power. Just depends on your structure and whatever you're using. Now, so this one, first thing I'm going to do is take that 1/3 and I'm going to distribute throughout the parentheses. To me, this is the easiest way and the best way to avoid mistakes. So I've distributed 3. It's an algebra step. Now I'm going to take each one of these numbers in front and make those exponents. And then I can go ahead and do this. I can make each of those radicals, because the 3, 1/3 is a fractional exponent, which means that the 1 stays as the exponent, and the 3 is the one that moves as the radical. So I'm going to do it for each one of those. And then my last step, which I need some more space. Now I can finally condense it down to one natural log. So I have addition, which means I can combine these two together with multiplication. And then this one is subtraction. That's why I have my division. And I can write it like that. Now I don't know what system you're using or what your instructor wants, but you can also write it like this. So just in case, you can, since these are all underneath the cube root, you can write it as wy over z. Now it is true you could have done it a whole lot faster way. You could have taken this and done the inside first, and you would have gotten natural log of wy over z. And that 1/3 would become the exponent, which means it would become the radical, the cube root. Hey, whatever you want to do. I did the long way to show you the possibilities of what you could do. But if you can see shortcuts, that's even better. And I did that shortcut again fairly quickly, but with a few more steps. I can write it as 1/3, and then natural log, and then I got addition. I can combine that with multiplication, and I have division or subtraction, which means division. Then I can take that 1/3 and move it out in front, or out as the exponent, and then I can take that 1/3 and write it as a cube root. Just another approach, however you want to do it. Now this last one, we have two natural logs being subtracted, which means I can use division. So I have x squared minus 4 on top and x plus 2 on the bottom. I'm not done because the top will factor. I need a little bit more space than that, so I'll save it for later. The top is going to factor. There's a difference of two squares, x minus 2, x plus 2, and the bottom stays as x plus 2. And then guess what those x plus 2's do? They cancel. The final answer is natural log of x minus 2. I don't know how much of this you're going to see, but just in case you see it, there you go. So there's all kinds of examples there to follow.